Hi and welcome back to Gaffy's Grinds. This is video 9 in our series on atoms, elements and the periodic table for junior cycle science. In our previous videos, we've learned about what elements and compounds are, and today we're going to look at chemical reactions and how compounds get formed. Okay, so let's take a look at this substance. Okay, so here we have a material. What I want us to do is I want us to think about the properties of the material. Now, on 3, I want you to speak your answer to the screen. I'm going to ask you a question. What is a property? So on 3, 1, 2, 3, speak your answer now. I hope you said that a property is a feature of a material that you can see or you can measure. So let's describe this property's appearance, because this material's appearance. If you can see them, if you can see the features, then that means that they are properties. Well, first of all, I suppose I would describe it as its color is you could either say gray or silver. I'm going to call it gray. It's gray or it's silvery. It's shiny. Okay, which means it reflects light. So it reflects light quite well, shiny. That's pretty much it for what you can see in terms of, its appearance. You might also notice that it's in a very thin ribbon. This is what we call a ribbon. So it's like a looped up loads. I'm hoping that as well that you can see that it's a metal and it's looped up into like a ribbon. This is what the property that allows us to do this, to make it really, really thin, and then so you have to hammer it into like a really flat sheet and then like twist it into a loop. We would call this, we would say that this substance is malleable. So we can bend it into a shape, into that looped shape, and roll it up into a ribbon. If you think about it's sitting on a desk, so it's probably at room temperature. So what its physical state is, we can see that it is a solid at room temperature. Room temp. It's a solid at room temp. And generally things that are solids at room temp, what does this say about their boiling points? Well, it tells us that they've probably got a high melting and boiling point, because it's at room temperature and it hasn't melted or boiled. So it's a high melting and boiling point. And most metals like this here would have high melting and boiling points. Okay. All right, that's pretty much it for the features that we can see, the appearance of this particular substance. I'm going to draw what the particles would look like if we were able to see them. Now, we can't see the particles, but a model that helps us describe what these would be like is, well, first of all, I'm going to draw 9 particles, and I'm going to draw them all touching each other in neat rows, predictable pattern. It's got 3, 3, 3, predictable pattern. This tells me that it's a solid when they're organized like this. So this is a solid material. The other thing I know is that it's an element. And the reason why I know that is because all the particles are the same. So this here is an element. Okay, so all the particles are the same. The name of this element, this is the element magnesium. Magnesium. You can find it on the periodic table. It's got its own little tile on the periodic table, which means that it's an element. All the atoms are the same of this. They're all magnesium atoms. And obviously, we've got these properties up here. All right, let's take a look at another material. All right, we're not looking at the glass. We're looking at what's inside the glass. Okay, so here we have a jar, and inside the glass, there is a substance. Okay, so again, we're going to think about the properties. Let's look at what we can see. Well, the first thing we can see is its color, or its actual lack of color. If something doesn't have a color, we say that it's colorless. So that's its appearance at the start. It's colorless. And we can't tell a lot else about it at the moment. We can tell, though, that it is a gas. It's a gas at room temperature. So if it's a gas at room temperature, what does that say about its melting and boiling points? It's a gas at room temp. If it's a gas at room temp, that tells me it has a low MP, which stands for melting point, and a low BP, which stands for boiling point. It has to, because it's already a gas and it's only at room temperature, which is not that high of a temperature. So it's already turned into a gas. But if we were to draw the particles that are going on here, well, here I'm going to draw a box to simulate the container. and I'm going to draw some particles. So I've got groups of 2 particles here, but you'll notice that they are all the same color. So they're all just red particles. They're in groups of 2, but they're all red. And they're quite spread out. They're not touching. So what information does this tell me? Well, this obviously tells me this type of diagram represents a gas. What type of substance is it? Is it an element, a compound, or a mixture? So on 3, speak your answer to the screen. 1, 2, 3. I hope that you said it's an element. I know it's an element because all the atoms are the same. They're all the same kind of atom, just one type of atom. They're all just that red atom. The last thing I'm supposed to know is, what is this substance? Well, this substance is the gas oxygen. It's oxygen. Again, you find it on the periodic table. It is an element. What we're going to look at now is what happens when we mix the 2 together and we do a chemical reaction with them. So we're going to watch this particular reaction now. Okay, we're going to watch a video of it, and I'm just going to speak to you as we watch it, see what we actually see. Okay, so hopefully this will play. Okay, so here, just set the scene. We have a Bunsen burner. That's obviously going to supply some heat. And we've got 2 jars, one on the left over here and one on the right over here. Now you can't see it yet probably, but inside this jar over here on the right, there is what we call this here is a type of kind of spoon, and wrapped around the handle of the spoon is some of this magnesium ribbon. Okay, so hopefully, I'm not sure if you can see my mouse, my cursor. If I just draw, oh, you can't actually draw on the video either. So just watch for the bit wrapped around the spoon, some of this magnesium ribbon. So he's going to take out the magnesium ribbon. Here we go. And he's putting, as you can see, he's hanging the ribbon into the flame. This is going to start the chemical reaction. Okay. Now I want you to watch what happens. He's going to then put the magnesium ribbon into the other jar. And this jar contains the oxygen gas. So we've got the magnesium ribbon on the spoon, and then we've got a jar on the left, which is full of oxygen gas. And I want you to watch what happens when he mixes them together, and look for signs that a chemical reaction might be happening. Okay, so think about what you see. So remember what the magnesium looked like now. Okay, we've got a really bright light, and wow, he's put it into the, and look at this, he's put it into the oxygen, and we're getting smoke, you're getting a lot of light. Okay, you're getting this really bright light, and you're getting this pulsing light. Okay, it's really, really strong. It's obviously burning or something. Okay, so you're getting a lot of light, which suggests a lot of energy has been given out by wave transfer, because light is a form of a wave. And we also had smoke coming out the top, which again suggests a lot of heat. So it's either smoke or steam or something like that. There's a lot of heat going on. Okay. Now the reaction is finished. Okay, and again, I just want to make sure that you think about what tells us a chemical reaction is happening. So you're thinking about a lot of light going on, a lot of heat going on. Okay. Now, what I'm going to show you now is what the substance looks like after you do that. This is what you produced in that reaction. Okay. This is what we ended up with. So if you were to take the bits of the magnesium that will be stuck to that spoon after it's all burned and to crush it off, this is what you would get. Okay. You would get this here. Now, what's actually happening, before we go on, what's actually happening here, if we were to draw what was happening, here I'm drawing the atoms of magnesium. Here we've got this magnesium ribbon, and we've got these atoms of magnesium ribbon. Okay, what happens when a reaction starts happening? Well, normally in the air, we've got this oxygen floating around. This oxygen floating around in the air. So we've got these floating around, and at the moment, they're not really doing much. They might go in and they might bounce off the magnesium, but they're not really reacting until you provide that first bit of a spark from the Bunsen burner. And what happens then is you give enough energy for these 2 particles to start to collide, smash into each other and start to react. So what happens is that the oxygen moves towards and actually ends up sticking to the magnesium. So Here is the magnesium again. And now what you've got is you've got some of the oxygen particles colliding and reacting with the magnesium particles. And when they do this, they make this substance down here. So this is the new substance. Let's look at its properties. First of all, describe its color. And what can we see? We can see it's white. Now this is completely new property. The first two, neither of them were white. We had gray and we had colorless. Our new substance is white. This is telling us that this must be something new. Okay, it's not what we started with. It's a powdered solid. Powdered solid at room temperature. If I was to pick this up and try and like bend them or manipulate, change their shape, then they would crush up, they would just break apart. So they are not malleable like the magnesium was. They are the opposite. They are brittle, which means they will break easily if I try to change their shape. They are brittle. It will just crush up. Okay, so obviously that's a new property. So this substance has all new properties, and they're nothing like the two substances that we started with. So this is actually the really weird thing about chemical reactions. You can never actually predict what the properties of the compound is going to be. Now, if I was to draw the particles here, I would be looking at something like this. Okay, so I would have, now I have one magnesium combined with one oxygen. That would be what we would be looking at. So this is what the product would look like. One magnesium, one oxygen, one magnesium, one oxygen, one magnesium, one oxygen, and so on. Okay, so again, here we have different types of atoms chemically combined. So first of all, it's still a solid. We've got neat rows, predictable pattern, and it's a compound. So this is not an element anymore because we've got different types of atoms, compound. What is this compound called? Well, that usually depends on what elements we started with. We will do this, how to name these compounds in another video. But we've got this compound magnesium oxide. Kind of makes sense because we started with magnesium and oxygen. But it's definitely different from what we started with, and the properties of it are definitely different. So we've taken two elements, we've mixed them together, but we've done a chemical reaction on them, and they've made a new substance, a new compound. So that's how we can make compounds from elements. All right, it's time to do some practice questions. All right, you should be well able to do all of these now, I think, without too much help. So what I want you to do is I want you to pause the video and do them questions now, please. All right, let's take a look at the answers. What was the appearance of the magnesium at the start of the reaction? So again, you should write a full sentence, but I'm just going to include the key word you definitely should have in your sentence. What was the appearance of the magnesium? So gray, solid, that's pretty much it. It was a gray solid. It was malleable, but that's not really an appearance. That's more of a feature that you can't see. Shiny, I suppose, gray solid, and it was shiny. That's another thing. Gray, shiny, solid. What was the appearance of the oxygen at the start of the reaction? Well, big thing here, this is colorless, and it was a colorless gas. So you should have them two in your answer. Describe what you saw in the reaction. So things you should be talking about: heat. Well, you can't really see heat, sorry, so it shouldn't really describe. We saw light, and it wasn't just light, it was very bright light, very bright light. We saw some smoke, which suggests heat, but we can't see heat, so we're just looking at smoke. So we saw light, we saw heat, smoke, we saw very bright light. How can you tell that oxygen has a low melting point? Okay, so hopefully you're saying that it's a gas at room temperature. That's how we know it has gas at room temp. Again, you should not just have these short answers, you should have a full sentence. How can you tell that oxygen is a non-metal? Well, if you look it up on the periodic table, if you didn't know how to answer this, have a look at it on the periodic table. Think about that. Pause the video and do that. Answer the question now. Okay, so it's on the right of the step line on the periodic table. I suppose you could also tell because the properties it has are of a non-metal, like it's a gas, it's low melting and boiling points, it's not malleable, it's not, you know, doesn't have the properties of a metal, but it's better to say this. It's on the right of the step line in the periodic table. Magnesium is a metal. What properties would you expect it to have? So think about properties of metal. It'd be malleable. We might expect it to be a good conductor. What else would you expect if it was a metal? Probably quite hard compared to some non-metals. All right, so any of the properties of the metals that you said there would be good. Malleable, conductor, it's hard. That's pretty much it, right? Magnesium and oxygen react together to form magnesium oxide. Which of the highlighted substances are elements and which are compounds? Sorry, I forgot to highlight these, so I'm going to do that for you now. Magnesium, oxygen, and magnesium oxide. So which of the highlighted substances are elements and which are compounds? So pause the video and do that now. Okay, so hopefully you said magnesium is an element, oxygen is an element, and magnesium oxide is a compound. Well done. If you said that, good job. Magnesium is a white powdery solid. Explain why its properties are so different to the elements that make it up. Okay, so well, magnesium is a compound. That's the difference. It's a compound. It's a new substance. Compounds do not always have the exact same properties as the elements that make them up, as we've seen here. So that was magnesium oxide, very different properties to the elements that made it up. So that is the reason why. So why its properties so different, because it's a compound, it's a mixture of the two, but it's a combined, like a chemically combined mixture of the two. And compounds do not always have the same properties as the elements that make it up. All right. Let's take a look at another example now. Okay, so similarly, we're going to look at these two substances. Okay, so taking a look at these two substances, right, have a look at them there yourself and tell me, what do you think in terms of properties? So have a think about that now, these two substances here. What properties do they have? Okay, first of all, let's look at this one over here. This is a gray substance. It's gray in color, so that's its first property. It's dark gray. These are little shavings of metal. So they are metal, and as you can see, they are stuck to a magnet. So that means that they are magnetic. So that is a property of this material, that it is magnetic. We can see that. It is obviously also a solid. We can see that it is a solid. It's behaving as if it's a solid. It's definitely not a liquid and it's not a gas. If we were to draw this, what would we be looking at? Well, if I was to draw this, I would be looking at a solid. So I would draw 9 particles arranged in neat rows. And you notice here, so this is a solid. All the particles are the same color. They're the same atom, so it's an element. And this element is actually called iron. This is iron. This is the element iron. Okay, now iron is often in big, like solid lumps. You might have seen like iron in like building, if you saw any bit of your house being built, sometimes we use iron. They're in big lumps. Bridges are often built out of iron, but these are like this stuff here is what we call iron filings, which is where you take one of those pieces of iron and you use a file to file it down, and these are like the little shavings off a big piece of iron. So that's what this is, iron filings. This substance is quite different. This substance has a color that it is, well, we would describe it as yellow. It's yellow in color. We can see that. That's its appearance at the beginning. We can see it, so it's a property. It will be non-magnetic. It doesn't stick to a magnet. Non-magnetic is not a metal, so it's not going to be magnetic. It looks obviously to be a solid. And if we were to draw it, we will probably represent it like this. So we have a container, And we generally, if we're drawing solids, we use 9 as our number of particles. And we do 1, 2, 3, 1, 2, 3, 1, 2, 3, like that. Okay, so this tells me that this is an element because all the atoms are the same. Element. It is a solid because the particles are arranged in regular patterns. And I can see that from the picture that it's a solid. And the name of this element is sulfur. This is the element sulfur. If you look on the periodic table, you will see that sulfur is there. It is an element. What we're going to do is, again, we're going to look at what happens when we put these two things together and we react to them. So I'm going to do the same thing. I'm going to explain as we watch the video. All right. All right, so first of all, you see here, we've got some iron filings in a beaker, and we are using a magnet to actually show that these are quite magnetic. As you can see, the magnet is making all the particles move. We are now mixing together the iron and the sulfur, mixing them together. Now, they haven't reacted yet. This is just a mixture at the moment. No chemical reaction has actually happened yet. And if you see, we're going to try and use the magnet. Oh, well, the magnet could actually be used to separate this mixture because the iron is attracted to the magnet, but the sulfur is not. So you could attract all the iron and leave the sulfur behind. Now we're going to add some heat, and this is going to cause the reaction to start. Now, how do we know a reaction is happening? Let's watch. So the Bunsen burner is heating it up. That's enough energy to get this reaction to start. Now, look, we've got a change in appearance. We've got this kind of, first of all, like a black color. Oh, and now we've got like a really bright red. So we've got a change in color. And we've also got this brown or reddish gas produced up here. All right, so gas is being produced. That tells us that a reaction is happening. We've got this bright glow of light. So again, light, so energy is involved. And this is our product at the end. It's cooled down. We're just going to use a little hammer here to just smash the test tube to get out the product or the stuff that has been left over at the end. Okay. And you see now its appearance is quite different. It's like a browny solid now. Okay, you see up here, you see on the top right. Now just check again, look at the magnet attracting the iron in the beaker of the mixture. But now this is after the chemical reaction, and this substance that has been formed is showing no attraction whatsoever to the magnet. Okay, checking again a different magnet. As you can see, no attraction whatsoever. It's not causing it to move. It's not causing that to happen. But again, if you bring the magnet towards the mixture, definitely it's still magnetic because the iron is still there. Okay, let's take a look again, remembering what we started with. We started with iron on the left, this gray magnetic solid, and this sulfur, which is yellow non-magnetic powdery solid. Okay, this here is the product. Okay, this here is the product. What are its properties? Well, it's kind of a browny color compared to the other ones. It's brown, or it's supposed that you could, some people might still call it gray. I think it's more browny. It looks to me to be a solid, quite a hard solid maybe. And we've learned from the video that it's definitely non-magnetic. So it has the property that it's not magnetic, non-magnetic. All right, if we were to draw it, how would we draw it? Well, obviously it's still a solid, but we'd have to draw it now. We're going to use 9 particles to show a solid again. But instead of all being the same atom, we now have different atoms chemically combined. And the different atoms are the iron and the sulfur atoms. Okay, because that's what we started with. So they obviously need to be in the products. So this is what we're going to actually end up with here. We're going to end up with 1 sulfur for every 1 iron. So you see one iron, 1 sulfur, 1 iron, 1 sulfur, 1 iron, 1 sulfur. You get this repeating pattern. Now this tells me that it is a solid because of the way the particles are arranged. What type of a substance is it? Well, it's not an element anymore because I don't have just one type of atom. I have more than one type of atom chemically combined. So I'm going to say that it's a compound. So it's a compound formed from the original 2 elements, iron and sulfur, and it has the name iron sulfide. Iron sulfide. This is the compound. And again, it has different properties because when we make a compound, They don't have the exact same properties as the elements that we started with. Sometimes they're really, really different. They can be completely different substance. Like you can form a gas, like when you start with two solids, you mix them together and it makes a gas. It's like really weird. It's like, how did you make a gas? That's so different. But you have to remember that compounds they're not just some random mixture of the features of the things you start with, of the elements that you start with. They can be completely different set of properties. And that's why it's so interesting that we can have all these different materials in the world with all the elements and then all the compounds that they can make. And that's what gives us this massive variety of different materials with different properties that we can use for different things. Okay, let's do some more practice. All right, let's take a look at these questions. All right, you should be able to do 1 to 4 really easily. So let's pause the video and do that now. Okay, so you should only be watching it if you've done this. Obviously, you take out your periodic table, look for the symbols for iron and sulfur. Sulfur is a capital S. Well done, if you got that right. And iron, a little bit harder to find because it doesn't begin with an I. It's F, capital F, lowercase e. Well done, if you got that right. Good job. F and Fe and S. How many protons, neutrons, and electrons are in iron and sulfur? Okay, so Fe. Actually, I just need to pause the video because I need to get my own periodic table here. Okay, we're back again. So Fe has, we have Fe 26 protons, 26p, 26e. It's got to have the same number of electrons, and it's got 56 minus 26, 56 take away 26, 30 neutrons. Well done, if you got that right. And sulfur, S, let's do that one. Sulfur has 16 protons. If it has 16 protons, it has to have 16 electrons, and then it's got 32 minus 16 equals 16 neutrons. If you're really not sure how to do that at this stage, you're going to need to go back and watch the video and where we did atomic calculations. Okay. Number 3, why is the number of electrons always equal to the number of protons in an atom of iron? Well, it's because the charges must balance. So each proton has a positive charge, each electron has a negative charge. You have the same amount of each one so that you've got a neutral charge overall, so that you've got the same amount of pluses and the same amount of minuses. Draw an atom of sulfur showing all the electrons. So we've got S in the middle. So we've got to draw, we've worked out we had 16 electrons. So we need to draw 16 electrons. We know we're allowed 2 in the first shell. We're allowed 8 in the second shell. That gives me 10 so far. And that means I need to put 6 in the third shell. 1, 2, 3, 4, 5, 6. Well done. You got that right. Iron, right, last two. This is where you got to look at these again. Iron is magnetic, sulfur is not. When they are mixed together, they can be separated with a magnet. Explain why. Okay. So what I want to do is I want to pause the video and answer number 5. So how can a magnet help separate this mixture? Well, they are mixed together. They are not chemically combined yet. Okay, so it's only after a chemical reaction happens does the properties change. So when you just mix them together, they still have the properties of iron and sulfur. So at this stage, iron is attracted to the magnet. But sulfur is not. So you can use the magnet to just pick out the iron. They have not reacted yet. So they have not reacted yet. They are still just iron and sulfur in a mixture. Okay. Last one though, when they have chemically bonded, you cannot separate them with a magnet. Explain why. All right, let's pause the video and answer that one now. Okay, so the key thing here is you should definitely mention that they formed a new compound. No, not that one. Okay. Oops, sorry. Okay, so they formed a new compound. They have formed a new compound. When they form a new compound, you can't separate them anymore. It's really hard to separate because the atoms are actually stuck together now. Okay, so compounds are difficult to separate. difficult to separate. The compound is non-magnetic. Is non or not magnetic. Okay, so once they're chemically bonded, you made a new compound, and that is much harder to separate than just when they're mixed together. The compound is not magnetic, so the magnet's not going to have any impact. It's not going to be able to drag the iron out of the compound. Okay, so they're actually physically stuck together now, and that's why you can't use a magnet on them. All right, so today you have learned about how compounds get formed from their elements. So we've looked at two big examples, and we've learned that elements mix together to form compounds, and that once they mix together to form compounds, sometimes or usually the compound has different properties, and sometimes be completely different properties to the elements that formed the compound. Okay, so you don't actually just like randomly take, I'm going to take two properties from that element, two properties from that element, and that's going to roughly give me the properties of the product. Sometimes it won't be like that at all. They'll be completely different properties. So that's an important thing to remember. New properties and also compounds are very hard to separate. Once you put them together, you can't just use a magnet to take them apart. It doesn't work like that. They're much more tightly held together. The magnet's no good. It can't just rip out the iron atoms anymore. All right, guys, that was it. I hope you found the video useful. I hope you're able to answer the questions. If you found it easy to follow, do leave us a like, please. And if you have any comments, if you want me to make any videos for you in the future, do leave it in the comments below. Thank you. See you in the next one.